guys, welcome to APchemistry course. In today's lesson I'm going to talk about gas stoichiometry. Alright, so what is gas stoichiometry? It's when we have normal stoichiometry and we're just including gas into it. So we need to find out the number either of products formed or reactants formed. Alright, that's not a problem. So let's start. So first things first, we have the reaction. Magnesium nitride reacts with excess amount of water to produce ammonia gas and magnesium hydroxide. If 5 liters of gas was produced at 126.85 Celsius degrees and pressure of 2 atm, how many grams of magnesium nitride reacted in the reaction? Well, if we rewrite everything, if we reread everything, and we underline the givens and circle what should we answer, it will be easier for us to solve. Alright, so we said magnesium nitride reacts with excess amount of water. If they said the excess amount of water, what does that mean? It means we have extra amount of water that we don't really care how much water we used, and that means that water will be the excess reactant. But what about the other reactant, magnesium nitride? If that's excess reactant, then magnesium nitride must be the limiting reactant, as it will have a limited amount of magnesium nitride that it will just when it reacts with the water, the excess amount of water, when this finishes, the reaction will stop. So that's why it's limiting the reaction. Alright, so next, we have 5 liters of gas, which is ammonia, because they said here gas, and we have only gas as ammonia, and was produced at 126.85 Celsius and a pressure of 2 atm. We have pressure 2 atm. How many grams of Mg3N2 reacted in the reaction? That means they want to search for the number of magnesium nitride that we used in the reaction. Alright, that's pretty simple. So we'll just do stoichiometry. First things first, we convert the given into the reactants. So that means if we have here the 5 liters of 2NH3, then that means that the NH3 here is going to be the one converted into the reactant. What does that mean? It means we have NH3 given, but we don't know how much Mg3N2 reacted. So we can use the value of NH3 to get the value of Mg3N2. Pretty simple, right? But we should always remember, in stoichiometry, moles is the unit that should be used. Here we have 5 liters of NH3. We don't have moles. It's not a big deal. In order to fix that, we can just use ideal gas law formula in order to solve such thing. Alright, do you remember the ideal gas formula? You're right. If you do, then you just go ahead and write it as PV equals nRT. If you don't, you can go back to the playlist of gases and watch the video about ideal gas law, and you can learn about the formula. Alright, we can use this formula to get the number of moles, but there's something wrong about it. We don't have moles in one side of the equation. To fix that, what can we do? You're right, we can put the n in one side of the equation. By cancelling units, we can have n in one side of the equation. The new equation will be n equals PV over RT. Alright, we can use this formula right now. So let's start. We plug in the data according to, we have n equals pressure of 2 atm multiplied by the temperature. Did you notice something? We have the units of Celsius. As you remember, in ideal gas law, we don't use the temperature of Celsius as the temperature unit. We use Kelvin. Now, it's not a big deal. As you know, in the video, we showed how to convert number of Celsius into Kelvin, which has the formula of 273.15 added to the number of Celsius, that will equal to the number of Kelvin. So let's do that. 126.85. If we add that into 273.15, we get the answer of 273.15. That must be 400 Kelvin. So let's see, 126.85. We get the answer of 400 Kelvin. Not surprised. So we get the answer of 400 Kelvin, and we put the unit 400 Kelvin up, because you can see we have, we put the unit of Kelvin down, 400 Kelvin, because as you can see, temperature is down. Then we plug in the data of 5 liters, which is for the volume, right over here. R is going to be, because we have ATM, we're going to use the part of 0.0821 and has the unit of latim, liters and ATM over K mole. Alright, great. Let's cancel units now. We have kelvins here, kelvins there, because if we have a fraction this cancels this out. And then liters here, liters there, ATM up here, ATM down there. We're left with moles and nothing else. So if we do the math right now, we get the unit of moles, which is the needed unit, and we get the needed answer. So let's do the math. A fraction, 2 multiplied by 5, then divided by 0.0821 multiplied by 400, which is going to equal to 0.304 moles. So our mole that is given is going to be 0.304. So N equals 0.304 moles of NH3. Alright, great. So that's the first given. Next, because we converted the unit into moles, now we can convert moles of the product into moles of the reactant. Using the ratio that is given in the equation, we have 1 mole of magnesium nitride reacts with 6 moles of water to form 2 moles of ammonia and 3 moles of magnesium hydroxide. Now we can use the ratio 2 to 1 to convert the number of moles of ammonia into a number of moles of magnesium nitride. Alright, so let's do that. We have 0.304 moles of NH3. We always put the unit that we need to convert and get rid of first, then we'll put the multiplication sign and we'll put the fraction. So, what unit should be up and what unit should be down? Should the magnesium nitride be up or at the bottom? Or should the ammonia be at the top and or at the bottom? You're right. In order to cancel ammonia from the equation, we need to put it down. So we take the ratio 2 moles of NH3. I'll put the other ratio of magnesium hydroxide above, 1 mole of Mg3N2. Always remember, whenever you want to convert in stoichiometry from a reactant to product or product to reactant, you always use the mole ratio that is written in the equation. You cannot just simply do the math. You have to use the ratio, then you can do the math. So this cancels this out, moles of NH3 cancels moles of NH3. We're left with moles of Mg3N2. If we do the math, we get 0.304 multiplied by 1 over 2, which is going to be 0.105. We get the answer of 0.152 actually. The answer is going to be 0.152 as written in the calculator. What is the unit? You're right, moles of Mg3N2. So we get 0.152 moles of Mg3N2. Now, if your question mentions only what is the number of moles that reacted, then you're good to go. The question is over, you solved it. But in our question they said how many grams of Mg3N2. They're asking for the number of grams. That means we're not done yet. In order to solve such question, we need to use another conversion factor using molar mass. Why? Because in molar mass we get the mass in grams of the compound plus moles, the unit moles, to cancel moles out. That's pretty good, right? Yup, it is. So we'll multiply now a fraction. Delete that. Put a fraction and we multiply everything. So if we make it in a higher, 152 moles of Mg3N2 multiplied by the fraction. So in order to get rid of moles, where do you put moles in order to get rid of moles? Down or up? You're right, we write the units down. So always it's 1 mole, because you're going for the molar mass, which is always 1 mole of Mg3N2. Up, you put the mass, which is, if you use the periodic table and you open the periodic table and you calculate magnesium's weight, you put 3 of magnesium added to 2 nitrogen weight, we get 109.4 grams of Mg3N2. This, now we cancel units. Moles of Mg3, I put the 3 here, moles of Mg3N2, this cancels this out, we're left with the unit of grams of Mg3N2. Now let's do the math and we can get the answer. So 0.152 multiplied by 109.4 over 1. We get the answer of 16.62. So the number of grams is 16.62 grams of Mg3N2. So 16.62 grams of Mg3N2 reacted in this reaction to produce 5 liters of gas of ammonia. Alright, so this is all about the lesson, and this is how to solve the question using stoichiometry. Now remember, the rule is always using moles for conversion, and always remember, first things first, you convert the given from any unit into moles. If it's in moles, then don't worry, you're already set, so you don't have to convert moles back to moles because it's already given. So if you're not, then you just convert the given unit, like we have 5 liters, into moles, then from moles of that given into the moles that is unknown. Alright, so that's simple. And at the end, if they ask for the mass, then you can just use molar mass ratio, and that's it. Don't forget, whenever you're converting from the known into the unknown, use the ratio in the equation, because it's really important. Sometimes in chemistry they don't give you balanced equations, so you have to balance them. I have a video also about balancing equations, and you can watch it back in the channel. Alright, so this is all about our lesson for today, and I hope it was useful.